Everybody, today we are going to do section 5.2, which are the properties of functions. And the first thing that we're going to look at, we're going to talk about something that is called increasing, decreasing, or constant. And our goal is to decide, when we look at functions such as this picture, where does this function either increase, decrease, or constant, if at all? And the first sentence in this paragraph tells us, in many applications, it is useful to identify the intervals of the x-axis. So we are going to be focused on this x-axis, for which a function f is either increasing in value, decreasing in value, or is constant. Now, down here, it gives us the definitions of how do we know if something is increasing, how do we know if something is decreasing, how do we know if it's constant. Basically, what we're going to do is we're going to use our eyeballs, and we're going to scan along this x-axis. And as we scan along the x-axis, we want to know, as we go from left to right, the x's that we are seeing, are they increasing or decreasing? And so what happens is, when we do this, we want to know if we have an increasing, decreasing, or constant function. So we're going to just jump right down to example number 2 so that I can show you while talking. So in this example, we have the function given to us, f of x is equal to x minus 2 quantity squared minus 1. And the instructions in this problem say, determine the open intervals, this is important, determine the open intervals where the function is either increasing, decreasing, or constant. And so the first thing that I want to do is I want to come over here and I want to write an I for increasing, a D for decreasing, and a C for constant. Even if your function isn't doing one of these, we need to make that known. We can't just leave it off. So the first thing that we're going to do is we are going to talk about this open interval. When we discuss intervals of increasing, decreasing, or constant, we are always going to use parentheses, which is why the word open exists. We are not chopping stuff off and saying we're solving a solution. We're just eyeing parts of the number line. And so in this given example, we're going to put our eyeballs right here. These are your little eyes. And you're going to scan this x-axis. And as you scan the x-axis, you're asking yourself, what is my function doing? And so if this is your eyeball, these are your eyes, and as you scan from left to right, what is your function doing? What is this line doing? So as your eyes move, your pen is doing what? Oh, it looks like it's going down. And what does going down mean? Well, that means decreasing. And once we hit a certain point, which happens to be the vertex of this parabola right here, then the direction of our graph changes. And what happens next? As our eyes are still scanning this x-axis, hey, guess what? This line is going up, or it's increasing. And when we look at this parabola, I think that we can say that it's not constant. There is no flat part to this. And so our goal is to write our answers over here in interval notation from our picture. And so first up, I for increasing. Is our function increasing? And we said, yes, it is. And we need to know, up to the top where in the notes listed, we're looking at the x-axis. So we need to know on what x values does this function increase. Well, we happen to know that on the x-axis, somewhere over here is negative infinity, and somewhere over here is positive infinity. Here, at this particular point, is where my graph has changed directions. What is that x value? Well, it's the value 2. So we will say in our answer that from the x value of 2 all the way to positive infinity, our function is increasing. And we will create our interval 2 to infinity. And we have our increasing part done. The next type of activity that we're looking for is, does this function decrease? Well, you already had said in the beginning, yeah, it's going down, it's decreasing. Well, what x values does the decrease happen on? And so if you look at your x-axis in the form of a number line, somewhere way over here is negative infinity. And that's where it starts, and we know that because this arrow indicates so. So as we scan from negative infinity, the function is decreasing, decreasing. Oh, look, it stops decreasing right here. And what is that x value? Well, that x value is 2. And so we will say that our function is decreasing from negative infinity to positive 2. And again, both with parentheses. The last thing that we have to decide here is, does my function have a constant part? And a constant part means, is it flat? And I think you can see from this example, we know that this parabola is not flat. And we can't just leave it blank. We must say none, or not flat, or not constant, or something like that. And so this problem is completely finished. We have looked at our picture, we have examined that x-axis, we had said, hey, look, it decreases and then it increases, and we wrote those intervals down. The last thing that we want to do to check ourselves is we want to make sure that every single number that is on my x-axis is accounted for. And since this x-axis continues on forever to the negative infinity and to the positive infinity, we have to make sure that all numbers are present. We're going to start over here and say, okay, look, do we start with negative infinity? Yeah, we go from negative infinity to 2. Okay. And then we go from 2 to positive infinity. So the question is, have we covered all of the numbers from negative to positive infinity? Yes, we have. And so we can circle these. Here are my increasing, decreasing, and constant answers. And now this problem is done. When we get down to example 3x, as you can see, there are 3 more problems, and the goal is the same. We want to find where do our functions increase, decrease, and where are they constant. And so let's take a look at this first one. This is kind of a funny looking graph. It's not something that we will draw, but since it's in our problem set, we are going to give it a go. The first thing that I want you to notice about this particular problem, take a look at its x-axis. What you might notice is right here is -5 and right here is +5. There are not arrows, as there are on this problem, that indicate this x-axis goes on forever. So it looks to me like we're only dealing with numbers from -5 to +5. So keep that in mind. Our eyeballs, once again, are going to be right here on our x-axis. And as we scan the graph from left to right, what's happening? Well, it looks to me like we start right here at -5. And as we scan from left to right, this line is increasing. It's going up. And it stops going up right here. And then what happens to it? Well, as we scan from left to right, hey, guess what? This line's going down. And then it stops going down right here. And then it's flat for a little while. And so this is the first one, where we have a C for constant. And then it stops being flat, and then it goes up a little bit more. And then it stops. Whew. Okay, and so the question becomes, where is it increasing, where is it decreasing, and where is it constant? And how do we write that? So we're going to come down here, just like we did in the previous problem. I for increasing, D for decreasing, and C for constant. And we're going to say, all right, well, where is this thing increasing? And we'll start on the far left, and we'll work our way to the right. The very first thing it does is increase. And so the question becomes, what's that x value? Well, it starts at -5. And it's increasing, increasing. Hey, look, it stops increasing right here. What is that x value? Well, that's -2. And then it starts to decrease, and then it's called, hey, look, it's increasing again. And so we say, look, it increases from here to here. Well, what's this x value? Well, it's a 4, and it increases until the x of 5. And so we can parenthesize both of those. And in the past, when we had 2 intervals that we wanted to join, how we did that was we stuck the union symbol in between them. Now we're ready to talk about decreasing. So we've got this increasing and we've got this increasing. Does this function decrease? Does it go down? The answer to that is yes, right here, kind of in the middle. And so we say, all right, well, at this x, which is -2, it begins to decrease. It begins to go down. And it continues to decrease, and it continues to decrease until right here. What's that x value? Well, that's +2. And so we did our decreasing. And it only decreases in one instance, so that's it. And the last thing that we have to decide, is this graph constant? And I think you can see very easily, yes, there's a flat piece. Well, what are those x values? Well, it starts being flat here, which is an x of +2, and it stops being flat here, which is an x of a +4. And the last thing that we need to do in order to check ourselves, to make sure that we have all of our numbers, which happen to go from -5 to +5 on that x-axis included, we have to make sure that they're all represented here. So we're going to start with -5, which is this guy, and we're going to say, okay, well, the numbers from -5 to -2 are included. And, oh, look, the numbers from -2 to +2 are included. Oh, and then guess what? The numbers from +2 to +4 are included. And lastly, the numbers from +4 to +5 are included, which means all of the x values that are present on my x-axis are accounted for. And now we are finished. If you look at the second graph, this is the graph of a horizontal line. And I know it's a little hard to see, but it's this line. I'll highlight it. It's this line that's in question. And it is blue on my notes, but that's the function. And so the question, of course, is this increasing, decreasing, or constant? And before I do the looking, I want to go ahead and jot down the I and the D and the C for increasing, decreasing, and constant. And if you take a look, this is a horizontal line. And what we can see is completely flat. And since there are 2 arrows indicating that this particular line goes on this way forever, it's always going to be flat. And since we're back to a normal x-axis that we're used to, we know that it's flat forever. Well, how far does forever go to the left? That's -infinity. Oh, hold on, I've made a mistake. I'm sorry, this is constant. It's -infinity. And how far does it continue to the right, being flat? Well, all the way to +infinity. And does it ever increase? No, so we write none. Does it ever decrease? No, so we write none. And so in this particular problem, the only thing that's happening is this line just being flat. It's just being constant. And so here are our final answers. It's not increasing. It's not going up. It's not decreasing. It's not going down. It's only ever constant, aka flat. And so now this problem is done. If you take a look at the third graph, what you see is a linear equation. And the question, of course, becomes, is this increasing? Is this decreasing? Is this constant? And so we will start by listing out the I for increasing, the D for decreasing, and the C for constant. And once again, we are looking only at the x-axis, and so we will glue our eyeballs right here. And as our eyes scan from left to right, what's going on with your blue function? So if these are my eyes, and I am scanning, it looks to me like as I go from left to right with my eyes, my line's going up. In fact, it is. It's actually just going up. And what I can see at the end are two arrows, which indicate this behavior lasts forever. And as it turns out, this particular function is only ever going up. So it's only ever increasing. And the question, of course, is what are the intervals on which it's increasing? Well, since we have our x-axis back to normal, and we know it's far from negative to positive infinity, everywhere we look, this is an increasing function. So it increases from negative infinity to positive infinity, the whole entire way. It never decreases, so we write none. And it's never constant, it's never flat. So once again, we write none. And there you have it. We only have an increasing function. Okay, so we have to flip the page now. And what we're going to discuss is a second type of property of functions. And this is called the local extrema. And before we read any of the paragraph stuff, I want you to focus on these two parabolas in the middle. A couple of days ago in class, we had parabolas that look like this. And we said, hey, look, here is the vertex. And pretend on this one, since it is an opening up, we called this a minimum point. And we had a parabola that was opening downward. And we said, hey, look, this is its vertex. And we called this a maximum point. Well, what happens is not every single graph, such as this one below, only has one vertex. And you're like, well, how can that be? Well, the definition of vertex is a point at which your graph changes direction. And when we talk about direction, we're talking about increasing, decreasing, and constant. And so when we only have a parabola, these parabolas, they only change direction one time. But in an example below, this actually changes direction several times. And so it is our task now to take a look at this graph, which has 1, 2, 3 vertexes listed, and decide what is the max, what is the min, where is it increasing, where is it decreasing, things like that. And so we're going to bounce back up here for just a moment, and we're going to say we have these two new definitions called a local maximum and a local minimum. And informally, when we talk about them, it just says that a local maximum of a function is the highest of all nearby points, which means the local minimum is the lowest of all nearby points. And in these two guys, in these two parabolas, since there is only one, we can get away with calling this the min, and we can get away with calling this the max. But when we get down to this guy, we clearly have 1, 2, 3 points at which our graph, or which our function, will change direction. So our goal is to decide, based on that definition of what a local min and what a local max are, which are these? And once we make that decision, we have to make our answer make sense. And so for example number 4, it says that figure 10 shows a graph of function f, so it's this guy. Step A says to determine the locations and the types of the local extrema of this function. And so what that means is, where are they, and are they max or mins? And then step B says, okay, well, while you're at it, go ahead and determine the values of the local extrema. And we're actually going to do this in one fell swoop. So if we go back to our graph, I think it's pretty clear to see that there are 3 points at which this graph is changing directions. And again, it's just kind of a reminder. Let's talk about what that changing directions mean. So if you take a look at the left-hand side and you scan from left to right, the first thing that's happening is your graph is decreasing. It hits this point, and now it's increasing. It hits this point, and now it's decreasing just a smidge. And then it hits this point, and it's increasing once more. And so you can see that there are more than one directional changes. And so our goal is to go piece by piece by piece, find the point, decide if it's what we call a local max or local min, and then we have to write what its value is. So the first point that I have highlighted, this is the point -1, -2. And the question becomes, out of this whole graph, would this be considered a minimum point of our graph or a maximum point? Well, how do you know? In class the other day, we talked about the maximum point being a high point, and we talked about a minimum point being a low point. And since this is a low point, we're going to call this guy our local min. And you can abbreviate, or you can write minimum if you want. It's whatever you want. Then we hit the next point, which is this guy, which is the point, 2, And the question is the same. Is this point 2, would we consider it to be a local minimum or a local maximum? And again, how do you know? Well, look at the other points. Is this point 2, is it higher than some of the points around it, or is it lower? Well, it is higher, which means this is a local max. And so now we have one more to go. Last point, this is the 0.41, and the question remains, hey, is this a local min or is this a local max? And when you take a look at it, how you figure this out is, look at the points around it. Is this particular point a low point on our graph or is it a high point? Well, this guy's higher, so this guy's lower. This is a local min as well. Now, since we have labeled them, it is now our task to make this answer make sense and write a statement essentially. And so we have 3 points, and we are supposed to find the locations. Okay, we did. Find the types. Okay, we did. Now we have to find the values. And we're going to be able to write a sentence to make that happen. And we are going to start off with the point on the left, and we're going to work our way over. And so the leftmost point, we're going to write in words. The local, and this one was a min, so the local min, that occurs at, where does this occur? Ooh, what do I mean by that? Let's take a side note. When you see the word at, I'm asking you for the x. And so, where does it occur at? What is the x value? Well, the x value is -1. Okay, there's where it occurs. What's its value? Well, you're going to see the word is, and when you see the word is, I'm asking you for the y. Well, what is that value? It's -2. And so we have made a sentence that reads, the local minimum that occurs at -1 is -2. And this word min, and this number -1, and this number -2, these are going to be things that change for each point. And so if you take a look at the next point, our goal is to write it out just like this. This one's a local max, so we will write the local max, and again, you're going to see we're putting in max or min, at, where is it occurring at? What is its x value? Oh, it's just 2. And when we find where it occurs at, what is its value? Oh, it happens to be 2. That's a coincidence. That doesn't always happen. And so there's my second statement. And my third statement, I have a local min. So I will start by saying the local min. And again, I'm going to underline min. Where does it occur at? What is its x value? At 4 is, and then a 1. And so you can see each point is going to correspond with one of these statements. And as you're working on your homework and your classwork and even your Hawks, the way that these are going to be asked is find the location. Okay, we did. Find the type, max or min, and then find their values. And we've done all of that right here in this little paragraph, I suppose. So we have completed the notes for this section, and you are now ready to work on your classwork as well as your Hawks. And if you have any questions, then you need to reach out to your teacher ASAP. Thank you.